Nebraska is the nation's leader in irrigated acres of farmland. The state had about 8.3 million acres under irrigation in 2013. That's ahead of the 7.5 million acres in California, according to the USDA's 2013 Farm and Ranch Irrigation Study. Nebraska Extension's Bill Kranz is an irrigation specialist located at the Haskell Ag Lab in Concord and has been studying, among other things, the efficiency of center pivot units. An aspect of that is whether the use of variable frequency drives on electric systems are profitable over the long run. We talked with Bill near Concord Wednesday to learn more about his research and started by asking about variable frequency drives.
Well, basically it's a unit that's put on an electric powered irrigation motor to change the speed of the motor and therefore the pump, and change the pumping characteristics on the fly based upon placing a sensor at the pump output.
And the purpose of it would be what?
Basically, if you look at the way the center pivots are designed and operate, particularly under rolling terrain, we have systems that are out there where we design them based upon being able to supply water to the top of the hill at a certain flow rate and pressure, the worst case scenario for that particular field site. The rest of the field requires less pressure than that to basically distribute water to the field site. And so the idea is that you put this unit on, you sense the pressure somewhere on the irrigation system itself, and you feed that information into a controller. The controller says, I don't need that much pressure right now. It changes the frequency of the electric power supplied to the electric motor, and therefore can adjust that speed to make the requirements that the system actually needs. Now, what we run into is that some of our field installations have end guns on that are only on in the corners of the center pivot, not on the full circle. Then we have systems that are, and particularly on specialty crops, that are placed out there and they have a corner system, which means they come into the corner of a square and off the end of the circle comes a swing arm. And it swings out into the corner and picks up another 5 or 6 acres of that corner and goes on. Well, what happens then is when that center pivot comes around, when that arm starts to swing out, the irrigation flow rate requirement goes up. The pressure remains the same, but the flow rate goes up. So if you have a constant speed electric motor, the pressure drops at the pump outlet, and you've got some different pump efficiency kind of thing going on.
You did some work on this and studying a number of different units around the state. Describe that.
Well, basically what we did is a grad student by the name of Dilshad Brar went and we identified 10 counties across the state that had different topography, they had different kinds of irrigation systems, they had different amounts of water that they apply per year. So we went across the state of Nebraska and we chose field sites that had quarter section center pivots, basically 1,000 of them statewide. And what we did then was we took the digital elevation maps for that field site and superimposed a standard size center pivot in that site. By doing that, we can calculate the hydraulics of every degree of that system goes around in a circle and add the pluses and minuses of being in different positions around the field and determine how much could potentially be saved by putting a variable frequency drive out there. And then at the end of the day, could you pay for it in the expected lifetime of 15 years or so of operation? What's the answer? The answer is this. If you have a center pivot with no end gun on it at all, chances are you'll never pay for it. If you put an end gun on, if you have a lot of elevation change on the field, you could potentially pay for it. If you have a corner arm on that center pivot, you almost always will pay for it. And if you put the end gun on the end of that corner arm, you will pay for it in less than 15 years.
No matter the elevation change?
No matter the elevation change. And the reason is because you have that major change in flow rate that goes on as that system comes out into the corner.
So if a producer's thinking about doing it on their operation, are there any other things they need to consider other than those 3 factors?
You know, basically if they want to do it from an economical point of view, elevation change, corner arm, end gun, that's it. You know, there are other things out there, but if you can adjust the speed of the pump to maintain efficiency, that's the other part of that equation. But that really is a smaller part than the others.
You can find more information about this topic through an article Bill recently wrote on Crop Watch. We'll link to that story on the Market Journal homepage.